Hi, I'm Jesse with Mastercam, and in this video, we're going to be talking about how dynamic work offset can save you a lot of time both in Mastercam and at the machine. Dynamic Work Offset, or DWO, is a software feature in your control that makes setting up 4 and 5 axis jobs incredibly easy. It allows you to locate the part and fixture anywhere on the machine's table or platter, regardless of the world origin in Mastercam. Before we talk about DWO, we should take a quick moment to point out that DWO is used for 3+1 or 3+2 toolpaths where the B and C axes are locked during cutting. And it shouldn't be confused with tool center point control. TCPC is for full simultaneous 5-axis toolpaths. If you're interested in more information on TCPC, there is another video in this series which covers it in depth. Let's start out by taking a look at a couple different ways to easily create planes and how those planes relate to using DWO on your control. The part we'll be using for this demo is a mold for a computer tower. The Mastercam top plane is currently located below the machine's table. If we didn't have DWO available, everything would have to be translated to a location that correctly represented the center of rotation on the machine. With DWO, we can leave everything where it is and simply create the planes that are needed, and DWO will handle the offsets at runtime. To start, let's create the plane that represents how we're going to pick up the origin of the fixture on the machine. We'll turn off the level with the mold geometry on it to get a better view and then drag and drop the gnomon onto the top of the fixture. The Z-axis is correct, but the origin of this plane is not currently in the center of this face on the fixture. To center it, we can simply click on the axis we want to move and slide the gnomon to the center autocursor position for the parallel outer face. I'll repeat this with the other axis, and the gnomon is now perfectly centered. There's one other thing that we need to adjust, and that's the orientation of the X and Y axis. We need the long axis of the part to be aligned with X. To fix this, simply grab an arc segment on the XY plane of the gnomon and rotate it until it's aligned correctly. If the cursor is outside the angle increment displayed around the gnomon, you can choose any angle. If the cursor is inside, the angle will automatically snap to whole numbers. You can also align the rotation of the axis by choosing an autocursor point on the model, which is what we will do here. Now the X-axis is perfectly aligned, and this plane accurately represents my G54 fixture offset at the machine. I'll name it G54 offset so that it's easily recognizable inside the Planes Manager. Lastly, I'll set the offset to 0 so that it correlates to the correct offset at the machine. At this point, I could also set this plane as my active WCS, construction plane, and tool plane if I wanted. Or, after the plane is created, I could simply make sure it's highlighted in the Planes Manager and click the equals button. With this setup, we can turn the model back on in the Levels Manager and look at machining a feature on the part. Let's machine this slot on the side of the part. In order to position to this face, a B-axis tilt of 90 degrees and a C-axis rotation of 90 degrees will be required. However, as a programmer, I really don't need to worry about that. Mastercam only needs a plane located on that part face with the Z-axis normal to the feature to be cut. We don't have to worry about the direction of the X and Y axes, since the post-processor will automatically align this offset to the primary tilt direction for the table. Let's name this plane Side Feature 1, set the offset to 0, and select it as the C and T plane. We won't set this plane as the WCS, since the difference between the WCS of our main G54 plane and the orientation of this new plane is what will trigger the B and C axis rotation in the machine. If you're currently using a machine without DWO, then you're probably used to this type of thing, except that your offset would be coming from the machine's center of rotation. Thanks to G254, that's no longer a requirement. We're now ready to program a toolpath. For the sake of this demonstration, let's create a simple contour operation. We can use the cavities option in the chaining dialog and then simply select the side of the part. Mastercam will automatically chain the top edge of the feature for us. On the planes page, we can see that the WCS is our G54 plane, and the C and T planes correspond to the plane we created for this operation. If this wasn't correct because we forgot to preset this in the Planes Manager, we could easily change it here. On the tool page, we'll pick a small bullnose end mill. The default cut parameters should work fine for this feature, so now we'll set up the linking parameters. We'll set everything to absolute and use the depth button to select an appropriate point on the floor of the feature. We'll set the top of stock the same way, then manually enter a feed plane value that gives us a 250 thousandths clearance from the top of the stock. Since this is a 3+2 part with indexing, we'll give ourselves a little extra retract height to be safe. Looking at the toolpath and backplot, we can see the motion is clean and that this should be ready to run at the machine. Before we head over to the machine, it's important to note that DWO is an option that needs to be enabled on your next-gen control. DWO comes standard on machines like this UMC, but is an optional purchase on other machines. Lastly, you need to make sure your Mastercam post-processor supports G254. So make sure to verify with your post-processor provider that this option is enabled and configured in your post. Once we post out the code, we can see the G254 following the initial C and B axis rotations. Let's load it on the control and see this cut in action. As this toolpath runs, we can see that even though the axis commands in the G-code are output with respect to the G54 fixture offset, the control is compensating to the proper X, Y, and Z positions relative to the center of rotation. To prove this point further, let's move the fixture for the part, pick up the new fixture location, then rerun the exact same code. Without DWO, you would have to go back into Mastercam and shift all the planes for this operation to reflect the new location relative to the center of rotation. With DWO, you simply pick up the new fixture location and hit cycle start. Hopefully, after seeing this demo, you get a good sense for the power and advantages of dynamic work offsets on a Haas CNC, as well as the ease of plane creation in Mastercam. You should now be armed with the knowledge to take on your next 3+2 job with confidence and efficiency. And don't forget to check out the tool center point control video so you can apply the same ease of workflow to your simultaneous 5-axis parts as well.